Hello everybody, and welcome to another repair video from Retro to Fix. Today we have a console that a customer dropped off and they said it has no power. When you press the power button you get no response at all, and they asked if I would record a video of the repair for them. Initially I thought it was a power supply, so I connected a power to the power supply and I checked the voltage at the fan, and we are getting our 12 volts at the fan, but we do get zero response when we press the power button. So most likely it's not a bad power supply. So we're going to go ahead and take this thing apart and we are going to find out what's wrong. It looks like the system has already been worked on because the tamper sticker has already been taken off. It was put back, but it has been removed at some point. Okay, we have all the screws out of the fan, so we can go ahead and remove the fan. We also have all the screws out of the top plate, so we'll go ahead and remove the top plate. Looks like they have a expansion card, so let's remove that. Now we can remove the top plate. Alright, the top plate is removed. I like to disconnect both sides of the disk drive when it's taped down, just so you can, bypass removing that tape and damaging it. Now we're going to remove the antennas and try and save these stickers as best we can. They're not always salvageable, but if we can save them, we save them. And we did an okay job saving them. Okay, now we can get to the totally necessary amount of screws to remove the top plate here. If you're ever taking one of these apart yourself, you'll notice that the holes where the screws go actually have no notches on them. If the screw has notches like this hole has or this hole has, that means the screw does not go there. It helps you when you're putting it back together, but when you've done as many as I have, you pretty much can put them back together without even looking. got all of the screws off, so we can go ahead and remove this top plate and get down to our main board. And now we're going to take out our main board. And we're going to release this cable by pressing down on the metal clip. Now we can pull this board out. It is going to feel like you're pulling too hard because it does have thermal pads that are holding it down a little bit, but just give it a little bit of a snug pull and it will come out. There you go. All right, our board is all the way out. So now we can see if we can figure out what is causing this board to not power up. The first thing I'm going to do is I'm going to inject some power into the system. I've got my power injector set to 2 amps and 12 volts. And we are going to connect the positive to the positive terminal and the negative to any ground anywhere on the system here. So we'll just connect it right there. This should pull about 320 milliamps. If it doesn't, that will possibly lead us in the direction of what is causing this issue. So I'm going to go ahead and press the output button, and we are getting basically 0 milliamps. 0 milliamps typically means a bad fuse. So the first thing we are going to do is we are going to look at all the fuses. Okay, now we are going to go take a look at the board here and find all the fuses and see if we can find a fuse that's bad. So we're going to set our meter to continuity mode, and we are looking to make sure that there's continuity through all of the fuses. So we'll go around the board here and we'll locate all of the fuses and we'll test them. Alright, so we have a fuse right here. That fuse is good. Alright, we have a fuse up here. Oh, there it is, sorry. And we will check this fuse, and we're good there. Let's see, rotating around on the board here. We have a fuse right here. I'm going to check that fuse. Okay. Oh, there we go. Never mind. Alright. That fuse is good. Thought we had one there for a second. Alright, we got a fuse down here. We'll check that. That fuse is good. Then we have 2 fuses up here. That fuse is good. And this fuse is good. Okay. Now we're going to rotate around. We have a fuse right here. And we're going to see if that fuse is good. Yep, that fuse is good. And I think that's all the fuses on this side of the board. Yep, I do believe that's it. Alright, there are a couple fuses over here on the other side of the board. So let's check those real fast. Let's see here. We got one fuse here. You can see that all the fuses are marked with the F before the lettering, or before the numbering. That means it's a fuse. That fuse is good. And I think there's one more on this side somewhere, but I'm not seeing it. Oh. Actually not seeing another one, so that may be the only fuse on this side. I think so. Okay, so we know it's not a fuse now because we've tested all the fuses. So now we just want to look for a short in any of the common places that shorts occur. The first thing we're going to check is make sure that there's not a short on the 12-volt rail here. So we'll connect our probe to our hot lead and to our ground and see if there's continuity, and there is not. So there's not a short on the 12-volt rail. Another place where we typically find shorts are on these banks of caps right here. So we're going to check all these and see if any of these are shorted out. So we'll just touch both sides, and if we have a cap where both sides are shorted to ground, then we know that that bank is bad. Okay, all those banks are good. Okay, let's see. Another thing we can check while we're here is we'll see if the HDMI encoder chip is shorted out. So here's our HDMI encoder chip, and we just want to check all of these caps here and see if any of them are shorted out. I need to get a probe. Okay, we're not seeing any shorts here. So it's most likely not the HDMI encoder chip. And then we're just going to randomly go around and try and find some caps here and see if we find anything else that's shorted. So we'll check these caps here. And maybe these here. Nope. Good there. We'll check this bank up here. I've seen this bank have several shorts on previous systems that had power issues. So check in here. We don't have to check them all because, as you can see, this is all one big plate here. So if it's not shorted there, then you know it's not going to be shorted here as well. So we don't have to check the rest of those. Okay, we got no shorts there. Another place that's a good place to check is up here on the RF circuit, or the Wi-Fi circuit. So let's see if any of these caps are shorted out.
I don't know if it's a bee or what. Marie is messing around with me.
Okay, we don't see any shorts up there. We can check these two caps here. We can check these. See if there's a short here.
Dad, is that come out here? Yes. Do not come here. It's a dangerous chaos.
We had no short here. And no short there either. Okay. So I'm not seeing any shorts on this side of the board. We pretty much checked out the common thing. Okay, so we didn't see any shorts on the other side, so now we are going to go ahead and test this side and see if we see any shorts over here. The first place we want to look is probably on the south bridge, see if we've got any shorts here on the south bridge. And right there, we do have a short on the south bridge. So this is most likely our problem here. This cap right here is shorted on the south bridge, which doesn't mean this cap is bad. It most likely means that the south bridge is bad. So we're going to go ahead and probably swap out that south bridge. We're going to do some quick looks here in a couple other places, make sure there's no other shorts. We'll check down here in this area here. And I don't see any shorts around here. And we'll check right up here, and we'll see if we see any shorts up here. And we appear to be good there as well. So it looks like the only short that we have there is on the south bridge. So we are going to go ahead and remove that south bridge, and we are going to put another south bridge on there. I'm going to go ahead and set that up, and then I will start the video back up again. Okay, so now we are all set up here to swap out our south bridge. This is our south bridge chip here, right here. So we're going to go ahead and remove the old one to start. So to remove it, we'll put a little bit of flux around it here, all the way around the outside edge. And we'll have our tweezers ready here, so I can find them. Just grab a new barrier. There they are. Okay, so we're going to have our tweezers ready, and we're going to heat up the south bridge, and we're just going to put our tweezers on each side here. And once it gets heated up, we'll just lift it right off. Alright, so our tweezers are ready. We bring in our hot air, and we are just going to heat up this south bridge until it's loose, and then we'll lift it off. It does take a little while for the heat to penetrate all the way through the chip and get all of the balls liquid. So we don't want to pull on it or anything like that. We want to just heat it up, and we'll kind of feel when it gives, and then we'll just lift it right up. If you do pull on it, you could risk pulling one of the pads off the board, and if you pull one of the pads off the board, at that point your system is pretty much toast. So this is something you have to be very careful with. Should be getting close now to letting go. So we're going to kind of gently move our fingers a little bit to see if there's any play in it. And there we go. Alright, our old south bridge is off. Okay. Now we need to clean up the old solder off of this south bridge so that we can have a nice clean surface to put our new reballed south bridge on. So to get these big globs of solder, I just take the soldering iron and just kind of rub it on all of them, and you can see it grabs them, and then I just clean it off, and I come back and I do that again until we get all the really big globs off. You don't really want to use your wick when you have these big globs, because the wick will be more likely to stick to the board, and then that can pull a pad off. So we want to try and get as many of these big globs as we possibly can off before we even consider doing wick. Okay, we got all the big globs off, it looks like to me. So we should have enough flux down there to actually use our wick now. So we're going to go ahead and just grab some wick here. Cut off a nice fresh piece, or get ourselves a fresh end here if I can find my knife. Okay. Now we got a nice clean end here, so we'll just go ahead and put our iron down on this wick, and we will rub it across all these pads and hopefully get as much solder off as we possibly can. As you can see, the wick is filling up with solder there. I want to make sure to not bump any components, so just stay in the area here where the Southbridge is. Okay. Now I think our surface looks pretty good. We're going to go ahead and wipe it down and take a look at it and see if we think it's good enough to put the new Southbridge on. So we're just wiping this with isopropyl alcohol. It's going to take probably a couple times because there is a lot of flux on here, and we want to make sure that we get all the flux off while we're checking to see if this is all cleaned up. So we wiped it once. Here comes a second pass. So see if we can get it all off, and we can look and see that this thing is pretty flat. We pretty much got it off, and we can look and see that this thing is pretty flat. We pretty much are ready to go ahead and put the new Southbridge on. So I think we are ready to go ahead. Here's our new Southbridge here. You can see it's already reballed. Here's our new Southbridge here. You can see it's already reballed that we're putting on here. So we're going to go ahead and new Southbridge that we're putting on here. First of all, we want to put down a thin layer of. First of all, we want to put down a thin layer the Southbridge in place. So I put just a little dab on my finger, Southbridge, and I kind of just rub it. I put just a little dab on my finger. It's going to go. And you don't want too much flux under there, because if you have too much flux, when you put your Southbridge on, you don't want too much flux under there, because if you have too much flux when you put your Southbridge on, the flux can cause a short, and it can cause your Southbridge replacement to not work. Before we do put that other Southbridge on as well, I'm going to flip this over, and we're going to check that spot where we had a short before, and we're going to make sure that our short is gone. I'm sure it is, but I always like to check. Oops, our meter turned off here. Turn it back on. So we have a short on this side, and we don't have a short on that side. So removing the Southbridge did remove that short. So let's flip it back over here. Get our Southbridge replaced. So you can see at each corner of this chip there are tiny little squares to let you know where to line up the chip. So there's a square there, there's a square there. Let's see. Sorry, I believe it's this square, and then can't really see the square over here due to the flux, but I can see. Let's see. I have to stand up here. So you have a square right here. You have a square right here, and I think that's it. I'm not really seeing them very well. Might be. Actually, now that I look at this, I don't think this one has squares. Typically they do have squares, and you can line up pretty easy based on those squares. But it's looking like this one doesn't have the typical alignment squares that you would use. So we're just going to have to kind of align this one by eye here. Okay. That looks decent. I think maybe this side needs to go up just a hair. Okay, I think we're good right there. So we are going to go ahead and apply some solder, and we're going to apply some heat and get this thing soldered down. Yeah, I'm feeling very confident about that location. So let's go ahead and get our heat, and let's solder this thing down here. So we're going to apply some heat. Try and apply the heat evenly over top of the chip, and you will start to see it bubble a little bit as the flux underneath it gets warm. We're just doing our best to keep as even of a coat of heat as we can, so that we can get all the solder balls nice and hot. sometimes when this thing gets hot and it mounts itself, you'll actually see it kind of pop into place where it aligns with the balls perfectly. But if you have it perfectly centered, it won't do that. In this case, I think we got it pretty centered, so I don't think we're going to see this chip move very much. But we'll just make sure we get it all nice and hot, evenly distributed across the entire chip. And we'll do that for about a minute or so until we start to see the solder around the chip. The components around the chip start to get hot. Then we know that our solder balls are probably hot as well. So we'll just keep applying the heat. And once we feel like we probably got it in place and everything has gotten hot, we'll remove our heat and we'll test it and see if the chip is mounted. So I think we're probably good there. So I'm going to go ahead and remove this heat. Okay, we remove the heat and then we give it a few seconds so that it can cool off. We did apply quite a bit of heat, so we just leave the heat, leave it setting for a minute and let it cool off a little bit. And then we give our Southbridge a little bit of a tap and we see if it moves. It's not moving, so it is down and secured. So now we are going to, first of all, check and see if we still have a short on the other side. That's the first thing we're going to check. So we'll flip this over and see if our short came back. So we'll grab our meter. We'll go ahead and test this. We should hear a beep on this side, and we should not hear a beep on this side. Okay, our short didn't come back, so now we are going to the correct amount of current now that we've replaced the Southbridge. So we're putting our probe back onto our hot line, and we're putting our ground basically to anywhere connecting to ground. And we output our voltage, and we are getting still 0. Okay, so that could mean that we have another problem, or it could also mean that our Southbridge isn't down all the way. So we are going to go ahead and apply some more flux to this, just a little thin coat around the outside here. And we're going to apply more heat to our Southbridge. That has got to be enough heat. Alright, now we are going to give that a few seconds to cool. Now we are going to clean it up a little bit because we added that additional flux. So we're going to clean up with a little bit of isopropyl alcohol around the edges to try and remove any excess flux that could be around the chip. We've cleaned that up now. Now we're going to go ahead and inject our voltage. Okay, now we have 318 milliamps of current. So that's what we should be looking for, is right around that 320 mark. So most likely this fixed our issue. So we're going to go ahead and turn the output power off, and we're going to disconnect both of our leads. And we're just going to quickly put this together, and we are going to test it and see if the system turns on now. Now we are going to go back into this thing and we are going to reflow the liquid metal and everything, but for right now we just want to put it back together and we want to see if the system is actually turning on and make sure that we are getting power before we start cleaning everything up and getting it ready to go back together. So I'm just going to push this board down. We're going to put the clamp on because the system will overheat so fast that we won't actually be able to see the video without having the clamp on. So I'm going to go ahead and put the clamp on right now, and then we'll turn this guy back on and we will see if it's working. Okay, we have our clamp on. Now we're going to go ahead and connect our power. And we are also going to connect our video cable. And we are going to press the power button and see what happens. Now, if we remember before, we got no light, no response at all when we pressed the power button. So here we are, we pressed the power button and we got a response. Oops, we forgot to connect our light. Okay, there's our blue light. So we do have a blue light coming on, so that's a good sign. So we're just going to wait for this blue light to turn white. And once it turns white, we'll look and see if the video is working. Okay, there's white. We're going to turn our TV on. And I'm going to pull the camera down so you can actually see this.
And that's a wrap. Thank you for tuning in for another amazing showcase of Retro to Fix, produced by 1100 Productions. This is your host, Jacob, signing off. If you've got a broken system or console and you need a repair, reach out 561-320-7580. Remember, drop a like, hit subscribe, and we'll see you on the next one. Thanks, everybody. Good night.